Our code and our report are telling us there are a few times where data were not available. Now, there's probably not enough of these times to worry about in terms of this being a viable data set, but ultimately it might be nice to show where there's not available data directly on our visualization. One way I like to do that is show places where data are not available with a red X that are directly on the edge of the plotting area. This implies to me that these are not valid values. In fact, they're not available values, but you can see where they are located on the x-axis, so you know something about when they occurred. So let's talk about how to add that to our graph. Ultimately, at some point in our graphing, we're going to want to decide how many NA values we have for a given week of data. And let's just go ahead and put this right after we are graphing our data points. Now, ultimately, if we want to put something that's right on the edge of our graph and we don't want to think about what point that is in terms of how much par that would represent, we again want to call plot.window and reset our xlim and ylim so that we still have a time scale on our x-axis. So our xlim and our xlim minimum and maximum are going to be the week start and the week end. But here's another point where we want our C to be on a relative scale. So just between 0 and 1, because we ultimately want to make it easy to figure out how to put things directly on the edge of the plotting area. Okay, so that should make things easier. Now we have to decide where we have in NA indices in a given week. So I'm going to define a variable called week NA indices. I'm going to find out how many NAs I have or where I have NAs using the isNA function. The isNA function will tell me in a given vector what are the indices of that vector where it found NAs. And I need to look at the week's worth of par data to look for NAs in the par data. So now I should have indices that will tell me something about whether there's NAs in particular elements for a given week's data. First of all, I basically don't want to do anything if there aren't any NAs. So I can use the any function on weak NA indices. So recall that weak NA indices, I think I can run this, is going to have a whole bunch of trues and falses corresponding to each element of weak par that tells me whether there's an NA or not. Now, I'm not sure I'm not gonna see any trues in this week of data that's being plotted, so I'm not gonna see any trues here, but ultimately there will be trues anywhere where an NA is found. So if I do an any on weak NA indices, it will tell me if any values in this whole vector are true or not. And if any of them are true, that's where I want to actually add to my plot. Otherwise, I don't need to do anything. So, excuse me, I'm going to start with a conditional to say I only want to plot things if I have NA values. Then if I do have NA values, I'm going to make a call to points to plot those NA values on the very edge of the axis. So my X is going to be my week time, but indexed by week NA indices, because I only want the times that correspond to where I have NAs in my par values. Now my Y values, I'm not actually plotting par here. I'm just going to put a red X on the edge. Again, I'm going to use the repeat function, the rep function. And I know that the Y value for the edge, when I'm using relative values of 0 and 1, when I know I'm using that 4% buffer, the very edge of the plotting area is going to be at a Y value of minus 0.04. That's that 4%. And I need to know how many of these weak NA indices have true values. So I'm going to use the sum function. And if I do a sum function on a vector of logical values, the trues will each count as 1. So it's going to sum up all of the trues, and that means I'm going to have the number of trues based on the sum, and that's the number of times I need to repeat this minus 0.04 to get a vector that I know is the same length as this week time indexed by week NA indices. Then I just need to, first of all, I need to use XPD equals true. That makes sure I'm not clipping any symbols if they go off the edge of my graph, which they will if I put things right on the edge. So I need to have XPD is true. I need to decide on a symbol to use. I like to use some sort of X, or in this case, an X with a box around it is the symbol number 7. And finally, I'm going to use red as the color for the particular symbol. So again, in review, I find out if I have any week indices for a given week of the PAR data. If I do, then I plot them as data points where the time is just the week time that's indexed by those indices, those ones corresponding with PAR. I need a number of y values that are all minus 0.04, but I need a count of them that's the same as the number of true values in weak NA indices, because that's how long this x vector is going to be. I need to turn XPD on to true to make sure that anything going off the edge of my plotting area doesn't get clipped. I need to tell it the symbol I want to use for the data points. In this case, this is going to be an X with a square around it. And then the color is going to be red for these symbols. So that's all there is to it. If I run this code, or this chunk, should regenerate my graph. Then I can go back to my plot, and I know that the first NA value, based on my report, should be on May 1st, keeping in mind that this is UTC time, and it's at 2:20 in the morning, so it's actually going to be on April 30th if I'm talking about Mountain Time. So if I scroll down to April 1st to 22nd, here is the week of April 25th, and on the evening of April 30th, sure enough, I have an X with a square around it at the particular time that NA happened in. In this case, it's going to be in Mountain Time. So if I keep scrolling down, there aren't very many of them, so it might take me a while to find one, but they should be really easy to see because of these red X's with a box around them right on the edge of the plotting area. And this just gives us a quick visual representation of where our NAs are occurring, which looks like it tends to be either around sunrise or sunset.